Yeah, good morning, students. Dear students, we commenced the discussion of ER diagrams, and let us continue the same. It is a recap of our previous discussion. In our previous class, we had a discussion on database users and administrators. You might have memorized in our last class, we discussed about the naive users, the users who knows nothing. There are application programmers who can develop application programs. There are sophisticated users who makes use of database using query processors. They are called sophisticated users. And of course, you are having a specialized users who makes use of the database for non-traditional purpose. For non-traditional purpose are nothing but they are sophisticated, specialized users. They are specialized users. Apart from this, there are database administrators. Database administrator who administrates the entire database is nothing but database administrators. And coming to the database administrators, they are responsible persons for the creation of the schema, for modification of schema, for specifying the accessing methods of the database, for maintenance of database, for backup recovery, all that stuff, the maintenance activities, the regular maintenance activities, whether the sufficient disk space is available or not, all this stuff is being taken care by the administrators. They are called database administrators. And also in our last class, we discussed about the database design in 6 steps. I explained you there are 6 steps in designing the database. The 6 steps for designing database are: 1, requirement analysis. The first step is requirement analysis. The second step is conceptual design. The second is conceptual design. The third is logical database design. These 3 designing activities are interrelated with ER diagrams. The first one is requirement analysis. The second is conceptual database design. Third is logical database design. Apart from this, you will be having the schema refinement, physical database design, applications and security design. So totally we take 6 steps. With the help of 6 steps, we will be doing the designing activities. That is a database design. And also I explained you what is meant by entities. Anything in the real world situation which is concrete or abstract in nature can be called as an entities. Entities are being identified with the help of attributes. For example, student is an entity. Student is an entity. The attributes of students are student number, name, class, total marks, and all this comes to attributes. Every entity will be having some attributes. For example, you take a doctor. Doctor is an entity. The doctor is identified with attributes: doctor number, doctor name, specialization, his experience, qualification. All these are the attributes with which you identify entity from the entity set. The similar types of entities put together, it becomes entity set. That is a set of entities. And also relationships and relationship set. This is what we discussed in the last class. Relationships and relationship sets. And entity is related to another entity. For example, lecturer is related to student. A student is related to lecturer. There is a relation. The student teaches to, the lecturer teaches to student. Lecturer teaches to student. So there is a relation between the lecturer and student. Similarly, a doctor treats. Treats is a relation. A doctor treats patient. That is how these 2 entities are associated. They got related to each other. Those are called as relationships. The similar set of relationships are called relationship sets. This is what we discussed in our previous class. This is a recap of our previous episode. Now, the outcomes expected in this episode. In today's class, the outcomes what we expect is relations. That is a binary relation, ternary relation. We would like to know what is meant by a binary relation, what is ternary relation, what is unary relation, what are instance diagrams, mapping cardinalities, weak entity sets, key constraints, and of course we would like to know what is a class hierarchy and aggregation. These are the topics expected to cover, and this should be the outcome of today's class. And let us commence today's class, that is about different types of relations. Let us commence with the different types of relations. My dear students, be alert. All of you, be alert. I'm going to discuss about the binary relation. Before construction of database, Just simply you should not go for the creation of database. Before going to the database, I want to store some data into the disk. Directly you should not create tables into the disk. Directly you should not create schemas into the disk. Better you go with the ER diagrams first. If you are comfortable with ER diagrams, then you convert these ER diagrams into a tabular forms and store the instance that is the data. For example, employees are working for departments. In a company, you are asked to create a database. When you are asked to create the database, first you need to study. In this company, what are there? There are some departments, and in each department, employees are working. This is what you noticed. You want to computerize that. You want to do some automation work there. You came to know there are some employees, and employees are categorized into some departments. They belong to production department, sales department, marketing department, finance department. So different employees are being categorized into different departments, various departments. And you want to computerize the entire stuff, automation. You want to go with the automation. Then you first draw ER diagrams. This is entity relationship diagrams. ER diagrams stands for entity relationship diagrams. The entity is represented with a rectangle. Employee is an entity, you put a rectangle. Department is an entity, you put a rectangle. How employee is being identified with the help of employee number, that is social security number, SSN, employee name and job designation. He may be job, may be manager, clerk, peon, office boy or officer, whatever may be. So employee is being identified with some attributes. These are called attributes. That is SSN, that is social security number, or we call employee number, name and job. Similarly, department is identified by department ID, department name and the budget allotted for the department. For production department operations, I allotted some 5 lakhs budget. For sales department, I allotted 10 lakhs budget. For marketing department, I allotted 20 lakhs budget. So every department will be having some seed amount, that is nothing but budgetary amount. I'm identifying the departments with the department ID and of course the name of the department and budget of the department. Employees are related to departments. Employees, they are managing the departments, or department is managing the employees. In other words, we are going with the employees are working for the departments. Employees are working for the departments. Employees are working for departments. Now you observe the diagram. Employees are managing or working for departments. Employees are working for the departments. This is what you are showing. This is nothing but a ER diagram, a rough ER diagram, you need to draw here. Later what we do is we create a table called employee with columns SSN, name and job. We create a table called departments with columns department ID, department name and budget. Means every entity set is being converted into a table with columns of department ID, department name and budget. Just we take one more example, binary relation. Binary, we are calling it as a binary relation. Binary is nothing but 2. Bi is 2. So one is employee, another is department. You observe here, doctor is treating patients. I'm using treating, treats. Treats is a relation, T-R-E-A-T-S. Is treating the patients. Doctor is treating the patients. Right? A doctor treats patient. Doctor treats patients. How doctor is identified? Doctor is identified by some number. Let me say it is a doctor number, name of the doctor and specialization. How patient is identified with patient number and patient name, patient number, patient name, patient number, patient name and problem. Every patient is having some problem. He is being identified with the problem. First we need to draw the diagram. For super specialty hospital, you are asked to create a database. I want to store the details of the complete transactions what are going in the super specialty hospital. Then what you need to do is you need to observe. You need to observe the real world situation. When you observe, you will come to know there are many doctors, there are some patients, blah, blah, blah. You will be observing, many observations you will be doing. Now you take a doctor. This is an entity set. A doctor is being recognized by doctor number, doctor name and specialization. Let me say is a doctor number. This is a doctor number. Doctor number, doctor name and specialization. And coming to the patients. Patients are identified by patient ID, patient name and problem. Doctors and patients are related. In what way they are related? Doctor is treating the patient. Doctor treats patients. This is the relationship set. This is called binary relation. It is called binary. It is called binary relation. Why we are calling it as a binary relation? Relation among two entities. Two entities. This is first entity and this is the second entity. Second entity. You are relating these two entities and you are depicting in the form of diagram, entity relationship diagram, ER diagram. This is called binary relation. Right? I hope so. You're following what is meant by a binary relation. You can take hell of examples. Here I take an employee department, doctor, patient. You can say lecturer, student, and so on and so on. You can take hell of example, n number of examples you can take. Now let me creep to the next one, that is a ternary relation. Let us go ahead with a ternary relation. And coming to this ternary relation, more than two, or we can go with the n-ry relation. N-ry relation. Ternary relation, three. You observe here more than two, I am showing. This is nothing but a ternary relation. Employees are managing departments. There are various employees who are managing departments. And these departments and employees, they are working on some projects. They are executing some projects. Employees, they are working for some departments. And the duty of employees and the departments are to execute mega projects. Employee is identified by employee number, name and job. Departments are identified by department ID, department name and budget. And projects are identified by project ID, cost of the project and project name. You observe here, this is the relationship set. This is a relationship set which is relating employees entity, department entity and projects entity. Once again, I just repeat, this is the relationship set. This is a relationship set which is connected to employees, departments as well as projects. Once again, you need to observe, employees are working for department, employees and departments, they are working for some projects. They are executing some projects and these projects is being connected. Here it is not binary relation. It is not a binary relation. It is a ternary relation. I'm going with more than two relations. That is employee entity set, department entity set and projects entity set. Employee entity set, department entity set, employee entity set, department entity set and projects entity set and projects entity set. All these are interconnected with this. This is more than two entities are getting connected and hence it is called as a ternary relation. Or sometimes we go with the n-ry relation. You can go with any number of links. I can go with one more entity set here. I can go with one more entity set here. Nothing wrong. More than two, it comes to ternary relations or n-ry relations. So binary relations means relation among two. Ternary relation is more than two. That is, it may be a 3 or 4 or whatever maybe, or sometimes we call it as n-ry relationship. So dear students, when you are asked to create a database for a big office or hospitals or educational institutions, the thing is you need to identify entities and the relationships and the attributes which are required for those entities, and you need to depict in the form of a diagram, and this is called as a ER diagram, stands for entity relationship diagram. ER diagram stands for entity relationship diagram. Let us go ahead with the unary relation. Unary relation. Unary means only one. Bi means two. Ternary means three or more. Unary means only one. one entity. For example, you take an employee. The employee is an entity set which is identified by employee number, name and job. Employee is an entity set which is being identified by employee number, name and job. Employee number, name and job. Here, an employee is supposed to report to employee. An employee is supposed to report to employee. One employee is subordinate, another employee is supervisor. Supervisor is also an employee. Subordinate is also an employee. So here there is all are employees. In a company, all are employees. There is only one entity set. A subordinate is reporting to this employee. The subordinate is reporting to supervisor. This employee that is subordinate is reporting to the another employee who is nothing but a supervisor. Supervisor is also an employee. Subordinate is also an employee. So here there is only one entity set. This is called unary relation. It is called unary relation. That is called unary relation. We go with the second example. Just we examine the first example, second example. Let us go with the second example. A person marries person. The person marries person. The first person is female, the second person is male. Both are persons. Both are persons. A person is identified by name of the person, age of person and qualification of the person. A person is marrying the person. First person gender is female, the second person gender is male. Person is marrying person. Here person is a single entity and hence I am calling it as a unary relation. As it is a single entity, I am calling it as unary relation. You can observe here, an employee is reporting to employee. Employee is reporting to employee. This is nothing but it is a unary relation. A person is marrying person. This is a unary relation. This is a unary relation. If you go with the binary relation, if one is linked to another, that comes to binary relation. If one entity got connected to another entity, second one. First entity is person, second entity is department. If this is the case, then it is called binary relation. Suppose more than two, if you are working, it is called ternary relation. More than two, if we are working, it is called ternary relation or n-ary relation. Suppose if the entity is connected to itself, it is called unary relation. Entity connecting to itself is called unary relation. I hope all of you are following, you are comfortable. Dear students, we just discussed this diagram. This is called instance diagram. We'll have a small note on the instance diagram. Suppose this is the ER diagram, employees and departments. Employees and departments. The same ER diagram what we witnessed previously. This is ER diagram. Let me say this is a ER diagram. I call this as an ER diagram, entity relationship diagram, ER diagram. Employees are working for departments. This is a rough diagram, overall picture, which is a ER diagram. Suppose if you take some data, take some data and show what is happening, that is called as an instance diagram. You observe this instance diagram. This is nothing but employees details. I am not taking all attributes. I am just concentrating on employee number. I am just concentrating on employee number. Employee number 101 is working for department 10. Employee number 102 also working for department 10. You observe the relation, instance diagram. Employee number 101 on so and so date, till so and so date, let me say 21/1/19, he worked for department number 10. This is employee entity set. This is department entity set. This is nothing but department entity set. This is the department entity set. This is employee entity set. 101, he worked for department 10 up to 21/1/19. Employee number 102 worked for department number 10, up to 25th March 2019. Employee number 102 worked for department 20, worked for department 20 up to 19/4/20. Employee number 103 worked for department 30 up to 16/6/20. Employee number 104, employee number 104 worked for department number 30. Employee number 104 worked for department number 30 up to 28/8/2020. This is called instance diagram. If you take some piece of data like 101, 102, 103, department number 10, 20, 30, and if you work out with some piece of data and you relate, then it is called instance diagram. A generalized diagram is a ER diagram. If you draw a specific diagram with some data, by taking some data, then it comes to ER diagram. Stands for entity relationship diagram. ER diagram, it stands for entity relationship diagram. You need to differentiate what is entity relationship diagram and instance diagram. A generalized diagram employs departments, that's all. I'm not saying 101 employee, 102 employee, 103 employee, department number 10, 20, 30. I'm not saying that. I'm just putting a generalized diagram. There are employees, there are departments, employees are working for departments. And there is a descriptive attribute date. There is a descriptive attribute date. You can observe here date. Employee so and so date, till so and so date they work for so and so department. So date is a descriptive attribute on the relationship set. For this you are asked to draw the instance diagram. I am drawing the instance diagram. 101 so and so date work for department 10. 102 so and so date he worked for department number 10. 102 then he is working for department number 20. 103 so and so date he worked for department number 30. 104 so and so date he is working for department number 30. This is nothing but it is an instance diagram. Here you can see many to many relation. For example, 102. 102 is working for department number 10 as well as 102 is working for department number 20. You can see 102 is working for department number 10. 102 is working for department number 20. That is many to many relation. You can go ahead with the many to many relation. For example, department number 30. Department number 30 received the services from employee number 103 as well as 104. In instance diagram, you can observe here many to many relation. Department number 30 is getting the services of employee number 103 as well as 104. That is a beauty. That is called as instance diagram. Sometimes in instance diagram, we can go with multiple instance diagrams. You observe here multiple instances. What I mean is, you observe this ER diagram, employees, location, department. You observe this ER diagram, employee, departments, locations. Employees are working for some departments and the departments are located at different locations. Let me say Delhi, Vizag, Mumbai, various locations the departments are located. Employees are working for departments, but departments are not at one location. Well, some departments are at Delhi, some departments are at Mumbai, some departments are at Vizag, and so on. This is a ER diagram which is depicting employees works for departments, works in some locations. The location is identified by location name and pin. Now, if you take an instance diagram is a sample diagram with the data. I am taking some data. 101 is an employee, so and so date. He is working for department number 10 and the department number 10 is at Delhi. You can observe here the department number 101 is at Delhi. 102 is worked on so and so date for department number 20 and that department number 20 is also at Delhi. Now you can observe 101 worked for department number 10 and department number 10 is at Delhi. 102 worked for department number 20 and the department number 20 is also at Delhi. 103 so and so date he is working for department number 30 and that is at Vizag. 104 is working for so and so date for department number 30 and that department 30 is at Mumbai. You can see the employee numbers, the departments, and the locations they are working. This is nothing but it is an instance diagram where we take some sample data, we work out. This is called instance diagram. Now topic is on mapping cardinalities. Mapping cardinalities. How one entity is related to another entity. The type of relation it maintains is being depicted by cardinality, that is called mapping cardinalities. In mapping cardinalities, you are having one-to-one. For example, you are having a customer and account. Yeah.
Screen is not visible. Yes, sir. Now it is. Yes, sir. Now visible.
Okay. We'll go ahead with the mapping cardinalities. The next topic is mapping cardinalities. The type of relation it maintains between the two entities is being depicted by mapping cardinalities. Under relations, you are having different types of relations, that is one-to-one relation, one-to-many relation, many-to-one relation, many-to-many relation. I just repeat, these are called mapping cardinalities. One-to-one relation, one-to-many relation, many-to-one relation, many-to-many relation. Each customer, if you put arrowhead, that implies each. If you put arrowhead, that implies each. Each customer is having, means one customer is having one account. The arrowhead represents one. The arrowhead represents one. One customer is having one account. One customer is having one account. That is one-to-one relation. If there are 10 customers, each customer is having one account, 10 customers, 10 account. This is a mapping cardinal. For example, I'll say lecturers, students. I'll say lecturers here. I'll say students here. Students here. I put an arrowhead. Each lecturer is teaching to only one student. Each lecturer is teaching to one student. If there is arrowhead, that implies it is one. One lecturer, one student. 10 lecturers, 10 students. Something like that. That is called one-to-one relation. One-to-many relation. You are having one-to-many relation. And coming to this one-to-many relation, each customer is having many accounts, bank accounts. Here you are having arrowhead, here you don't have arrowhead. If you don't have arrowhead, that implies it is M. M means many. If you are having arrowhead, that implies one. This is nothing but one-to-many. It is one-to-many. One-to-many. One customer is having more than one account. This is called one-to-many relation. You take many-to-one relation. Many customer, you don't have arrowhead. That implies many customers are having one account. It may be a joint account. Partnership, in partnership, many customers will have a common account. Many customers can have a single account. This is many-to-one. If there is arrowhead, that implies one, many-to-one. Many customers are having many accounts. Many customers are having many accounts. This is many-to-many. These are called mapping cardinalities. One-to-one, one customer, one account. Why I am saying one? Here you are having arrowheads. One customer, one account. One customer, many accounts. Many customers, one account. Many customers, many accounts. This is nothing but many-to-many relation. All these one-to-one, one-to-many, many-to-one, many-to-many, all these put together, they are called as mapping cardinalities. We call them as mapping cardinalities. You need to memorize. Now, while drawing ER diagrams, when you are going with the ER diagrams, relation between two entities we need to assess. Whether it is one-to-one, one-to-many. Suppose one lecturer is coming to class and teaching 60 students. One lecturer is coming to your class and teaching 60 students. In computer, I need to store the data of one lecturer and also I need to store the data of 60 students. It is one-to-many. One lecturer is dealing many students. That is one-to-many relation. So in real-time applications, you need to think of this. For example, a doctor is treating many patients. One doctor is treating many patients. Are you getting it? One doctor is treating many patients. Suppose many patients are coming visiting many doctors. He is a patient. Some patients are coming to Dr. Prem, and the same set of patients are going to Dr. Kumar. Then I say many doctors are treating many patients. It is a many to many relation, many to many relation. So these are called as mapping cardinalities: one to one to many to many, and many to one. Just we work out with some ER diagrams of that nature. ER diagrams, entity relationship diagrams. Many doctors are treating many patients. Many doctors are treating many patients. A problem is like this: many doctors are treating many patients. Each patient is prescribed many medicines. Each patient is prescribed many medicines. You are asked to draw ER diagrams. Listen carefully. Many doctors are treating many patients. Many doctors are treating many patients. Each patient is prescribed many medicines. Now you are asked to draw the ER diagram and create database for this. You listen this question carefully. Doctors, doctor number, doctor name. Patients, patient number, name, problem. Patient number, name and problem. Many doctors are treating many patients, and hence there is no arrowhead. I am not putting arrowhead. Means many doctors are treating many patients. Each patient, you observe here, there is arrowhead. You notice here, I am putting arrowhead there. Each patient is purchasing many medicines. Here you don't have arrowhead. Each patient is purchasing many medicines. So the problem is many doctors are treating many patients. Each patient is prescribed many medicines. So you are asked to create a database. Before creating the database, you need to go with the AR diagram. Here, this is how I created the diagram, ER diagram. Many doctors are treating many patients. Each patient is treating many, is prescribed with many medicines. Here you don't have the arrowhead. That implies many medicines. Here you are having arrowhead. Each patient is purchasing many medicines. This is the gist of the ER diagram. I expect you are following this explanation. Dear students, I am proceeding with the next example. Just I am going ahead with the next example. You observe here. A customer is having many vehicles. Each customer is having many vehicles. Each customer is having many vehicles. Each vehicle met with many accidents. Each claim is associated with an insurance, with many insurance. You observe the question carefully. Each customer is having many vehicles. Let me say a customer name is Prem. He is having many vehicles. He is having bike, he is having moped, he is having a car. So each customer is having many vehicles. You observe carefully. Each customer, there is arrowhead. Here I am writing 1. Here you don't have arrowhead. I am writing M, means many. Or you can, some textbooks they write N, means N number of vehicles. N means N number of vehicles. Some textbooks they write M, means many. Some textbooks they write as N for N number of vehicles. Each customer, arrowhead, owns vehicles, many vehicles. Each vehicle, arrowhead, you observe the arrowhead. Here I am putting arrowhead. Each vehicle, okay, met with accidents, many accidents. One vehicle met with many accidents. One vehicle met with many accidents. There are many accidents. For each accident, there are many claims. I am claiming, for each accident I am claiming the insurance company to pay the amount. Many claims I am doing. I went with life insurance, some vehicle insurance companies. There are many vehicle insurance companies. I am claiming to the many vehicle insurance companies. For every accident, I am trying to grab amount from the insurance companies. Many insurance companies. So each customer is having many vehicles. Each vehicle is with many accidents. And each claim is associated with insurance. So each claim, each one. So accident, whenever there is an accident, we claim the amount, damage amount, is with many insurance amounts. This is ER diagram. This is the ER diagram for customer, vehicle and insurance relation. Just a half minute. You go through this. You go through the diagram. You need to have a rigorous practice on all these ER diagrams. Right, students, you are asked to draw ER diagram. You first take down the question. All the students, you can take down the question. Each depot is with many buses. Listen to the question carefully. You are asked to draw the ER diagram by taking your own attributes. You can take your own attributes and you can draw. Each depot, bus depot, each depot is with many buses. Each bus is with many passengers. In each bus, there are many passengers. Each passenger is with many luggage. Each passenger with many luggage. He is carrying suitcase, he is carrying briefcase, baggage, and luggage. Each bus is with one driver. So here, when you go with the ternary relation, all of you, yeah, please mute your microphones. There is some disturbance. You can observe here, each depot is with many buses. There are many buses in each depot. Each bus is with many passengers. For every bus, there are many passengers to travel. Each passenger is with luggage. There are multiple luggages. And each bus is with one driver. So bus is associated with passengers as well as drivers. Bus is associated with passengers as well as drivers. Hello, am I audible?
Sir, yes, sir. Yes, sir.
Okay. So you are asked to draw ER diagram. This is a homework program for you. Dear students, please take this question and draw ER diagram. All of you, please take down, note down the question and draw ER diagram. That is your homework program. Make it fast. Let us go ahead with the next one. The next topic is key constraints. The next topic is key constraints. You observe here, a key is the attribute. A key is attribute with which entity can be identified from entity set. A key is an attribute with which entity can be identified from an entity set. It is to be underlined. The key is to be underlined. You observe here, in students, how I identify a student with the help of student number. If I call a roll number, that is unique in nature. It will not be duplicated. So that roll number of a student is nothing but it is a key. In a supermarket, there will be many products. For every product, there will be unique product number. That product number is a key. There are customers. For a supermarket, number of customers goes, and every customer is to be identified, and a customer number will be given. The customer number is a key. Coming to vehicles, every vehicle will be having a unique vehicle number, and vehicle number is a key with which you can identify that particular vehicle. While answering examinations, every student will be given a hall ticket number. Hall ticket number is unique in nature. It will not be duplicated, and hence hall ticket number is a key. So in our regular activities, for every entity we give some unique key, that is with which you identify the entity from the entity set. You will be identifying an entity from the entity set, from set of entities. We will identify one student from students with the help of a key, that is the roll number. We will identify a particular product from set of products, with the help of product number. While drawing ER diagrams, you need to give underline. For example, customer number, customer name, and so on. Customer number is given underline. You observe the point here. You observe the ER diagram. I am giving underline there. Why? That implies this is the key which will not be duplicated. Vehicle numbers. For example, you see this vehicle number. Vehicle number is given underline. Vehicle number is given underline. Why vehicle number is given underline? That is the key attribute with which you can identify. For example, accidents. Whenever there is an accident, the police registers FIR. First information report, FIR. FIR is given underline, that will not be duplicated. FIR is underlined, that will not be duplicated. So this is called as a key. In customers, customer number is a key. In vehicles, vehicle number is a key, which is given underline. Under accidents, FIR is taken as a key, which is given underline. Similarly, you can observe here insurance company. Under insurance company, there will be a policy number. We call it as a policy number. The policy number is given underline, means that is a key. So the attribute which is given underline is nothing but it is a key. The attribute with underline is nothing but it is a key. I hope so you are able to follow what is a key. A key is nothing but it is an attribute with which you can identify an entity from entity set, that is called as a key. So an entity set which is having a key is called a strong entity set. An entity set which will not have a key is called weak entity set. An entity set which is having a key is called strong entity set. Entity set which does not have a key is called weak entity set. Weak entity set. Entity set which is having a key is called strong entity set. Entity set without key is called weak entity set. For example, employee is identified by employee number. Employee number is a key. Underline. Employee number is a key which will not be duplicated. Employee name and salary. Let me say salary of the employee. This is nothing but the salary of employee. Employee number, name and salary of employee. Fine. Employee number is underlined. Means employee number is nothing but it is a key. Employee number is nothing but it is a key. Sometimes we are doing some policies for our employees. Insurance, life insurance policy. Policy is being taken for employees. And if something happens for the employee, the amount is to be given for their dependents. And hence in our database, we want to store dependents also. We want to store the details of dependent. Dependent name and age. Dependent name and age. I want to store the dependent person name and age. I am not giving any dependent number. I am not giving any dependent number here. Now, dependent name is stored, age is being stored, but dependent number is not given. So this does not have any primary key, and hence this is called as a weak entity set. This is called weak entity set. The dependent is a weak entity set because they don't have any key. This is called weak entity set. Employee is having a key. This is called strong entity set. Employee is a strong entity set and dependent don't have a key, and hence it is a weak entity set. A weak entity set is depicted with a thick lined box, a thick black lined box with an arrowhead, and always the weak entity set is dependent on the strong entity set. For example, if I say employee number 101, I can say his name, his salary and his dependents. If I say employee number 101, I can say his name, his salary and also I can say his dependents. Dependents don't have any special key. They don't have any number. For example, in college you take, every student is given roll number. But we maintain even the details of your parents, what your father do, your address, father profession, we store. Your father is not given any roll number. Based on your roll number, we try to identify your father. That's what. Based on the employee's roll number, you are identifying the dependent details, dependent name and age. And hence the dependent is a weak entity set. This is a weak entity set. This is a strong entity set because this is a strong entity set because the employee is having a key. This is strong entity set. This is a weak entity set. A weak entity set is a set which don't have a key, primary key. Then it is called as a weak entity set. A weak entity set is always dependent on strong entity set. A strong entity set is a set which is having a primary key. That's the point to be noticed from this slide. And coming to the weak entity set, it is also depicted by either a thick bordered line or a double rectangles. You observe here the double rectangles. Either you can do like that as I showed you in the previous slide like this, or also you can show a weak entity set like this with a double rectangles. With a double rectangles, if you draw, that shows this is a weak entity set and it is a weak entity set and it don't have any primary key. It is not having any primary key, right? That is the meaning of this weak entity set and strong entity set. Now let us go ahead with the next topic. Let us go ahead with the next topic of class hierarchy. Listen carefully. I'm going to discuss about the class hierarchy. Coming to the class hierarchy, here superclass subclass relation comes. Superclass subclass inheritance concepts comes into the picture. Example, I go with a class hierarchy example, employees. Every employee is having social security number, name and some IoT. And coming to these employees, there are two categories of employee. Is a relation. Employee is a hourly employee. Employee is a contract employee. You observe carefully. Under employees, there are two categories. Employee is a hourly employee. Employee is a contract employee. There are two categories. Hourly employee, how many hours they worked, they will charge per hour. They take the wages. Hourly wages, hours worked. He worked for 10 hours. Per hour he is charging 500 rupees. 500 into 10, 5,000 rupees he is charging. That is a style of attributes. Is an hourly employee. There is a contract employee. So contract, he will not bother about hours. For 1 year, what is the contract amount you are going to give? For 5 years, what is the contract amount you are going to give? That is nothing but it is a contract employees. So this is called, at the bottom level, we call specialization. At the top level, we call generalization. Employee, I am generally saying employee. I am generalizing it. All the employees, I am calling it as employees. So this is called generalization. This is called generalization. Employee. It is called generalization. This is generalization. Right? And if you come to the bottom, I'm saying he's an hourly employee, he's a contract employee. This is called specialization. This is called specialization. That is generalization. This is specialization. It is a specialization. The top is called generalization, the bottom is called specialization. This is easy relation. We call it as a class hierarchy, easy relation. For example, here I am saying a person. Person is identified by person name and SIN, some number, social security number, SIN, person. The person is a student, the person is a teacher. If you enter into a college environment, all are persons. In persons, you are having categories. Student is a person, teacher is a person. Student is identified by his GPA or the total marks. Teacher is identified by salary. So now this is called as the easy relation. The person is called generalization. The person is called generalization. If you come, the person is a teacher. If you say the person is a teacher, then it is called specialization. The person is a student. This is called specialization. Person is a student. Person is a teacher. If you come to the bottom level, this is called specialization. At the top level, we call it as generalization. This is called class hierarchy. What I taught you now is called class hierarchy. You observe here. Just I am quoting a few examples on this generalization and specialization. For example, a movie. Movie name, year and some genre of the movie. Under movie, there are different varieties of movie. Cartoon movies and you are having a nature films. The movies, under movies, you are having cartoon movies and nature films. When I say movie, this is called generalization. When I say movie is a cartoon, movie is a nature film, this is called specialization. The subclass comes to specialization, the superclass comes to generalization. Are you getting it? The subclass comes to generalization, superclass comes to generalization and the subclass comes to specialization. This is all about the generalization and specialization. This is called class hierarchy. And of course, coming to the cartoon movie, it got related with the voice. In cartoon movies, actors, they will give their voice over, and movie actor got connected to the cartoon films. There will be an actor name, birth date, date of birth and photo of the actor, etc., and the role for which the voice is being given. So if you observe this portion, you should come to know what is meant by generalization and specialization. Just we discuss one more small topic called aggregation. Aggregation. What is meant by aggregation? You observe here, when there is departments, there are projects. The responsibility of departments is to execute the projects. The responsibility of departments is to execute the projects. If there is a department, it is implied that there are projects. Finish. If there are departments, it is implied that they need to execute the projects. So departments are sponsoring projects, are working with projects. So these two are must and mandatory. Now what I'm doing is I'm putting in a dotted line box. This is called aggregation. I aggregated. If there is department, there are projects. Finish. Now the employees should relate to both. The employees should belong to department, employees should work with projects, both. Then what I done, this portion I made it as a dotted lines. This is called aggregation, and employee got connected. Employee monitors. Finish. I got connected to this dotted line. This shows that employees are related to both departments and projects. This diagram, I am aggregating these two with a dotted line. I am clubbing these two with dotted line. Now this entire stuff, that is entities and relations, they club together. Now for this entire stuff I want to relate. That is the reason here a relationship set is associated between the entity sets. Sometimes we have to model a relationship between the collection of entities and relations. I want to establish a relationship. I want to establish a relationship between collection of entities and relations. Already entities are there. This is an entity. This is an entity. Between entities and relation, here there is a relation. With these entities and relations, again I want to establish a relation. This is a relation which I am trying to establish with this. This is the relation which I am trying to establish with these entities and relations. Once again, sometimes we have to model a relationship. I want to create a relationship between collection of entities and relations. Already there are a collection of entities and relations. With this I want to again establish a relation. In such case, this entire stuff is placed in the dotted lines. We call it as an aggregation. Employees, monitors, this dotted lines box. What are these dotted line box? Departments as well as projects. So employees are responsible for both the departments and projects. That's the meaning. You see one more example on this. You just observe. We go with one more example on this. You observe here aggregation. Example on aggregation. There are some centers, training centers, coaching centers. The coaching centers are giving some courses, some C, C++, Java or whatever may be. There are some coaching centers. The coaching centers are giving some coaching. So coaching centers are offering some courses. Now a visitor comes or one student comes. He inquires. He need to inquire about the coaching center, who is the instructor, who is the manager, and how long the coaching center is running. He need to know the details of center as well as the course. He want to learn C language or Java language. He need to know about coaching center as well as course. Now what I done is the coaching centers are offering courses. These are being placed in the dotted lines, that is called aggregation. And now the visitor or the student who comes inquires about this dotted line. This dotted line is nothing but he is inquiring about the center as well as courses. This is called aggregation. The aggregation, always we put it in the dotted lines, the aggregation. Fine. So in this class, in our discussion, we came to know about the binary, ternary, unary relations. We came to know about the binary, ternary, unary relations. We came to know about the instance diagrams, one-to-one, one-to-many, many-to-one, and many-to-many mapping. Weak entity set, which does not have primary key is called weak entity set, and we came to know what is a strong entity set and weak entity set. We discussed about the strong entity sets and weak entity sets, and also we discussed about the key constraint attributes which are underlined. The primary key values are underlined. We discussed about class hierarchy, that is easy relation with the generalization and specialization concept, and also we had on aggregation. Aggregation is nothing but the clubbing of entities and relationships, and a new relation is being established which is called as aggregation. So with this, I would like to conclude today's topic.